See Lindelof videos, particle motion, and how to use your calculator on the AP exam. Um, this is from the 2002 Form B AP exam, AB. It says a particle moves along the x-axis, so its velocity at any time, t, for t is greater than or equal to 0 or less than or and equal to 16 is given by velocity. This is really, really important to us because we get used to being given a position function. Here we're given a velocity function. It says at time equals 0, the particle is at the origin. So we're going to start trying to figure this out a little bit. It says, at what time is the particle at rest? Justify your answer. And then the next part says, during what intervals is the particle moving to the left? Give your reasons. And lastly, it says, what is the acceleration of the particle at t equals 2? So this is what I did just to show you. I'm going to just run through it quickly. So I went here, and I saved the function like so. And the way I did that was I went here, I chose this, I chose one piece, and then it let me fill in all of this stuff, and then I just stored this thing. And because we have a sinusoidal function that may have some ripples to it, we might have repeating values. So that's why it's so important for us to put it in this interval form. So now all I'm going to do is this. I'm going to use my solve function on the calculator and say solve v of x is equal to 0, comma, x. And if you take a look at it, it gives us all of those answers. So it gives us 0, pi, 2 pi, 3 pi, 4 pi. And we have to be really careful because if you move over here, we also see that it's true at 5 pi. At 5 pi. And if you wonder why not 6 pi, well, 5 pi is about 5 times 3, and it's a little bit less than 16. And remember, we're on this interval, but certainly 6 times pi would be over 18, so that would be outside of our interval. So our answers here would be these, right? Our answers here would be these. So our answers would be, let's go to this, our answers here would be, so for A, we would say t equals pi, 2 pi, 3 pi, 4 pi, 5 pi, and then, you know what, I might write particle at rest. Particles at rest here. All right, so the second part says, at what intervals is the particle moving to the left? So this is what I would do. I would set this up like this, and I would say, this is a great piece of proof here. We have this interval with endpoints at 0 and 16. Then we have pi, 2 pi, 3 pi, 4 pi, 5 pi. I know these don't look even, but it doesn't matter at all. I call these pi, 2 pi, 3 pi, 4 pi, 5 pi. Right? And we know, so let this be t, and let this be the velocity at time is t. So at time is pi, the velocity is 0. 0 at 2 pi, 0 at 3 pi, 0 at 4 pi, 0 at 5 pi. Now we just need to kind of go in and fill in the blanks in between. So look what happens. I happen to know that it's going to be positive here, negative, positive, negative, positive, negative. So that gives us something. But check this out. This is a great way to see this. We can go to graphs and just put in v of x. And there's v of x right there. So we can tell, right? Remember that we know this is pi, this is 2 pi, 3 pi. You know what? Let me actually go here and check through my window. I'm actually kind of glad that happened. Window settings. So I'm going to say from, like -1 to 17, just so we can see everything. 17, enter. So that's our whole function here, isn't it? And we know that this is pi, this is 2 pi, this is 3 pi, this is 4 pi, and this is 5 pi. So look, we have velocity height is positive here, right? Velocity height is negative here, positive here, negative here, positive here. So that's how we can get this. Remember, if we have positive velocity, then our particle is moving to the right. If we have negative height velocity, that means our particle is moving to the left. All right? So I'm just going to go back and put those in. Going to go back and put those in and say, because we are asked, when is it moving left? Give reasons for your answer. So I'm going to say left from, t is greater than pi but less than 2 pi. T is greater than 3 pi but less than 4 pi. And lastly, t is greater than 5 pi, right? Greater than 5 pi but less than, be careful because the number here is 16, less than 16, and then I'm going to write C chart. All right? So I think that's just a really good way to do this. The last question is the acceleration question. It says at t equals 2, is the speed increasing or decreasing? So it says what is the acceleration? So we want, this is part C, so we want a of 2. And you're like, well, we don't have a at all. Well, we can get it really easily. Go back to your calculator. We already have the velocity function. So all I have to do is hit menu, hit calculus, derivative. We have this thing in terms of x, and we want ddx of vx. All right, check this out. Use your up cursor, hit enter, and then hit control store, and you save that as a of x. Enter, done. Now we wanted a of 2, right? So we have a of 2. Enter. That doesn't look good, but hit control this, and it gives us so here's what's important here. It asked us for that very specific value, didn't it? So because it did ask us for that very specific value, it's negative 5.129. So I'm going to go back here. Negative 5.129. And then check this out, though. So that's the first part of that question. The second part of that question asks us if the thing is speeding up or slowing down. So how do we figure that out? Well, we take v of 2 and we compare the signs. So v of 2 and v of 2, control enter to give a number, is positive. So we have a negative. When acceleration is negative, but velocity is positive. What matters is that their signs are different. So I'm going to go here and say, a of 2 is greater than 0. V of 2 is less than 0. Therefore, decrease speed. All right, and that's all I wanted to talk about. So I hope this was really helpful for you. This is going to be really handy if you do these problems over and over and over again with your calculator. Your calculator will give you a lot of good answers. Don't forget to write good calculus, though. All right? So thanks for watching. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. Thanks.